Afternoon. Wanted to quickly get a couple things up on the web for us for pre-calc. We're going to look at doing the inverse of our trig functions today. So let's take a look at if I've got just the basic first step. We want to see the sine inverse of radical 2 over 2. Basically what we're going to do is we're going to find whatever value is in here and you're going to work around your unit circle until you find it. So since it's sine, we're going to look for our y value. So in this case, I see it's right there. And the inverse tells me to find out which one it corresponds with as far as a radian or degrees. So in this case, I can say that this equals pi over 4, and that becomes my final answer. Number 10, same thing, arc sine and sine inverse, these two notations. So both arc sine and sine inverse, those mean the exact same thing. So I'm going to go around the unit circle on the y value, look for my radical 3 over 2, which in this case I see is right there, and it corresponds with pi over 3. So my solution here is going to be pi over 3, and I'm done. Yeah? So that's the first most basic thing we're going to take a look at. Let's see something a little bit more complicated. So we'll take a look at stuff like 35 and 36 where we have to do multiple type functions. So I want to take the arc cosine of the cosine of pi over 4. So start with the inside again. Sorry, hold on, let me clear up. So let's start with the inside again here. We want to look at pi over 4. This time I want to look at the cosine. So we're going to look at the x value. And so the cosine of pi over 4 is radical 2 over 2. So I want to basically find the arc cosine of radical 2 over 2. Well, in this case, I'm going to go around and find the x value of radical 2 over 2, which happens to be the exact same location. And so I work backwards, and I see it corresponds to our radian of pi over 4. So my answer here is pi over 4. And that's my final answer for that problem. So looking at number 36, same idea, but with degrees. I want to find the cosine of 60. Cosine of 60 is 1/2. Okay, then I'm going to take the cosine inverse of 1/2, which brings me back to pi over 3. So this equals pi over 3. Okay, so that's how we work forwards and backwards with our inverse statements with the trig stuff. Now let's see if I mix and match some of this stuff. And we'll take a look at an example such as can't really move that. Okay, take a look at an example such as one of these. So 53, the sine inverse of the cosine. So now start with the inside again. We're dealing with cosine of 2 pi over 3, so I'm going to go around my circle here, and I'm going to find that 2 pi over 3 is right there. My cosine value of it is -1/2, so I want to find the sine inverse of -1/2. And now this is where we have to make sure we're dealing inside of our domain. And so for the sine values, everything we're going to look at for sine is going to be on this side of our graph. So all the sine stuff is over here. Okay, all of our cosine stuff is the upper half. So I want all my values to be inside that domain for cosine. So again, going back, looking at sine, I want to find sine of -1/2. I'm going to look at my y values. As I work around this, I'm going to notice that right there is the sine of -1/2. Corresponds to 11 pi over 6. But again, our domain is going to be from negative pi over 2 to positive pi over 2. And so in this case, what we want to do is look at it going backwards. So it's basically a negative pi over 6. So that's what we're going to call this. We're going to call that negative pi over 6. Okay? So that value is what we're looking for. If we want something a little bit more complicated, let's look at something like 55 where we're doing the tangent of something. So start with arc cosine. You've got radical 3 over 2. We're looking for the x value. There it is. It corresponds to pi over 6. So basically what I'm trying to do is find the tan value of pi over 6. Tangent is our sine over cosine. So we're going to look at this. I'm going to say my sine is that over my cosine of that. And so we're going to end up with 1/2 divided by radical 3 over 2. We'll notice those 2's are going to cancel out. And so we're left with 1 over radical 3. We don't like this as an acceptable answer because of the radical in the denominator, so by rationalizing our denominator, we see that radical 3 over 3 becomes our final solution, and we're in good shape there. Okay, last thing we're going to take a look at as far as the trig functions go before solving equations is going to be an example like 69. So in this case, we have something that's not on our unit circle. So I noticed that 7 over 25 is not one of these values on our unit circle. So what do I do now? I want to build a triangle. So we're going to kind of build our own unit circle. Sorry, I'm drawing too fast for my computer. And then when we go to do that, I'm going to notice that cosine, based on our SOHCAHTOA, is our adjacent over hypotenuse. So I'm going to have a -7 adjacent side and a hypotenuse of 25. And that's going to help me build this triangle over here. And I can use my Pythagorean theorem to then figure out what that opposite side length is. We'll call A our -7. B will be our unknown side length. And then C is going to be our hypotenuse. And so when I do the math on this, we'll notice that B squared is going to equal, it's going to equal 24. Okay, this is one of those special triangles. I've done it several times, but you can do the math on it and you'll find out that B equals 24. So there's my side length. I want to then take this value and find the sine of this angle. I don't necessarily know what the angle is, but the sine is going to be our opposite over hypotenuse. So my newfound opposite side length, which is 24, over our hypotenuse, which was given, is 25. And there is my final answer. Okay? So that's the type of stuff we're going to be doing with those. And then the new stuff we started talking about today was solving the equation side of it. So let's take a look at an example like that. So for the equations, we want to find the principal roots of each equation. So in this case, what we want to do is isolate the trig function. So in this case, cosine x. To do that, I need to undo this multiplication. So we're going to end up with cosine of 2x is going to equal our radical 2 all over 2. And then to undo cosine, like we've talked about, we want to take the inverse of it. So x is going to equal the cosine inverse of radical 2 over 2. Well, in this case, this one actually is on our unit circle. So I can go back, take a look at my unit circle. Where is the x value? Radical 2 over 2. Sure enough, there it is, relates to pi over 4. So x is equal to pi over 4. If this is something that's not on our unit circle, you can always use your calculator and use the inverse button that we've talked about. And lastly, we'll finish off with this one. So 2 sine x, again, undo that multiplication. So we're going to end up with sine x is going to equal -1/2. I want to undo my sine, so x is going to equal the sine inverse of -1/2. Go around my y values until I find my -1/2, which happens to be right here. And that's going to correspond with, again, our negative, because when we work backwards, negative pi over 6. So x is going to equal negative pi over 6. All right. Hopefully this helps. Enjoy the weekend. We have a quiz on Tuesday covering pretty much all of that, plus the sum and difference identities and the double and half angles. Good luck. Let me know if you have any questions.